So, welcome everyone. Thank you for coming to Devoteam's offices. I'm Graham Zabel. I head up our DevOps practice here. I've been working here for 5.5 years. Before that, I was at Barclays for a decade. We are also a digital tech consultancy. We're a French company, actually, about 10,000 people, €1 billion in revenue. In the UK, we're fairly small, but we are a big company. So I'm going to talk, there's my title. It says CCon 2023 at the bottom. So any of you familiar with CCon, the CCon conferences? I know you guys are. Okay, so thankfully you haven't been to CCon. That was a conference about 6 weeks ago. And so this is the presentation I gave there. I'm going to change it up a little bit, I hope. How do we save cash and carbon? Here's the agenda. So we have a data problem, which I will get into. I'm going to talk a little bit about storage is cheap. It's another talk I gave at CCon last year, where I tried to argue that actually storage isn't cheap, but it's a kind of meme that you hear all over the place. Oh, just store it, storage is cheap. I'm going to try and show you that it's perhaps not as cheap as we think it is. Dark data, this concept of dark data. Some DevOps anti-patterns, DevOps data anti-patterns, and then hopefully what we can do about those things. Right. So here is a nice exponential graph about the volume of data that we create worldwide. And the y-axis? That's the y-axis, yeah. Y-axis in zettabytes. Anyone know how much a zettabyte is?
1,000 petabytes?
A trillion gigabytes. Yeah, trillion, same thing, I think. A trillion gigabytes. So it's even hard to conceptualize how much data that is. But if you take this little 2, so in 2010 we created 2 zettabytes of data around the world. 2 zettabytes is roughly equivalent to all the storage of every mobile device in the world. So that's about 2 zettabytes. We are now in 2023, 120. We're going to be growing by 10 times that much just next year, it's projected. So it's an exponential graph. More data means we need more electricity. Data is stored in data centers. So data centers need electricity, so that means more electricity, which generally means more carbon emissions. Some people will say, including some of my colleagues who work in our Google practice, well, Google's promised to be net zero by 2030. So that's okay then, isn't it? We're going to be net zero. Microsoft they're looking at building mini nuclear reactors to power their data centers. So that's okay. We'll be all right. The problem with this is we need to get off of oil and gas, and if at this rate of growth, we're going to need a lot of renewable energy just to satisfy our data needs, and it's not going to help us get off of oil and gas. So just to satisfy the growth of data, we're going to need a hell of a lot of energy. So the data problem continues. This is a result of a study by a guy at the Amsterdam Business School in the Netherlands. Came out a month or two ago. By 2027, AI servers could use between 85 and 130 terawatts annually. This is equivalent to the entire energy used by the Netherlands or Sweden or Argentina. This is some other headlines from last year in the UK. At one point in July last year, our electricity grids in West London were at capacity. So there was no more capacity for electricity. The M4 corridor, you're familiar with the M4 corridor, I learned recently is the second largest concentration of data centers in the world after Virginia. We're at capacity. We cannot build any more data centers in the M4 corridor. Holding out closer, is that better? Okay, sorry. There are I think 3 boroughs in London where they cannot build any more houses because there is not enough not enough electricity capacity. In the Netherlands, they have the same problem. In fact, our group CTO is Dutch. He's saying the entire country of the entire Netherlands region is at capacity. They have no more capacity for more data centers. So we've got this massive growth of data. And by the way, after I gave this talk at CCon, someone came up to me and said, "Oh, you didn't talk about quantum. That's another huge data consumer that's growing very quickly." So on the one hand, we've got this huge growth of data, and on the other hand, we are running out of capacity, running out of electricity capacity to power the data centers needed to store this. The problem continues. So this is a survey by NTT, which is a telecoms company in Japan, again released a couple months ago. It was a survey of several hundred CIOs and CTOs around data. And some of the results of this survey here, so 2/3 of those surveyed consider data complexity as their top sustainability challenge. And 41% of those people didn't know what to do, what was the best approach to take with all of this data. So hopefully I'm going to try and help figuring out some of those approaches to take. So I use this picture as an analogy of a data store, and this is from my talk last year on storage is cheap. So essentially, whenever you start with a new application, you get a new tool, you get a new Jira instance, a new Git repo instance, you start with an empty store. And as you start using it, lots and lots of data come in. Once the data is in any kind of store, whether it's an application, a database, a DevOps tool, whatever, once the data is in there, it's very, very hard to get that data out. Why is that? Well, because over time we lose focus about what's important. We don't know what parts of this data is important. A lot of the data, we don't tag it properly or label it properly. So 5 years down the road, we look back at data created 5 years ago. What is this? We don't know. Let's just keep it there. What's in prod stays in prod. This is kind of really fundamental. Once you get something in a production system, there's so much regulation and fear about what to do with this, we just tend to leave it there. And then there's FOD. Anyone know what FOD is?
Fear of deleting
Data. Very good. I made it up. So that's why no one hears. Yeah, so FOD, fear of deleting data. I'm going to talk a little bit more about that too in a second. Okay, so as these data stores get fuller and fuller of data, they get bigger and bigger until you get the virtual equivalent of this. So you have all of this data, all these boxes on the top shelf with no labels in them. We don't know what's in that stuff. We don't have time to figure out what's in that stuff. And often, if you use the analogy of a DevOps tool, like a Git repo or a Jira instance or whatever, often large enterprises will outsource the running of these tools, and the outsourced companies like a TCS or a Wipro or something like that, they are not incentivized to clean up this mess. They're just incentivized to keep it running. Yeah? So there's no incentive to clean up those boxes. Now, I used this photo last year. It took me hours to find a photo, find me a messy warehouse photo. This year, I went to Gen AI and said, draw me a picture of a messy warehouse. And I got this and it took me several minutes. So, that's the AI part of my talk, by the way. Same thing. Okay, so dark data. Anyone heard this term? Dark data. I just came across this term earlier this year, and it's kind of on my mind all the time now. So what is dark data? Wikipedia says dark data is data which is acquired through various computer network operations, but not used in any manner to derive insights for decision making. It's all the data in the cardboard boxes on the third shelf up in that warehouse. That NTT survey I just mentioned, the survey of the several hundred CIOs, CTOs, they said that 60% of their organization's data estate goes unused. We store all this data, we don't use it. This is a quote from a book by Jerry McGovern, a book he wrote called Worldwide Waste. He's saying 90% of data is never used again after 90 days after it was stored. So we are storing huge amounts of data and it's just sitting there not used. And this really came home. I mean, this can come home to you in so many ways, but I was in Paris at our head office a couple weeks ago, and I arrived on a Wednesday. It was a national holiday in France, and our office is very close to Montmartre, which is up on a hill. So I went to Montmartre. I had a couple hours to kill. I went to Montmartre and just sat on the steps overlooking Paris. It was lovely. The sun was going down. And I was facing opposite Montmartre. So Montmartre was behind me. And I was just looking at the people taking photos. And you just look. And it's an endless snapping of photos and videos. And you just think, this is one small tourist destination in the world. And every one of these photos is probably being stored somewhere in a cloud somewhere. And you just think the volume that we're creating is just mind-boggling. Every time you get a package delivered to your door now, someone takes a photo of it. My daughter's traveling in Asia right now, backpacking around Asia. And in the old days, we would send in the old days, we'd get photos developed, and then we'd send photos. Now she sends videos. Everything is a video. It's like a little TikTok video. So we just have videos like all over the place storing. So this amount of data we're storing, and as I said, there's IoT data, streaming data, gaming data, AI data, quantum data. So it's really, really crazy. So FinOps, can FinOps help us with this problem? FinOps has lots of great ideas. So FinOps is essentially, it's a cost, about how much does our cloud cost, but it's a proxy for carbon. If you lower your costs, ideally you're lowering your carbon emissions. And FinOps and the cloud hyperscalers have all these great ideas about how to save money with FinOps. Get rid of your orphan snapshots and your unattached volumes. Put it into Glacier. Use cold storage. It's cheaper. Optimize your storage costs. Use savings plan, etc. The one thing they never say is store less, right? They never say store less. And it's our interest, the interests of corporations and enterprises and the hyperscalers are fundamentally not aligned. Hyperscalers want to sell more storage. And enterprises are told, we've got to cut costs, we've got to save carbon, we've got to use less. So there's a fundamental disconnect, which I don't think we've really addressed yet. But so as a corporation, we're being told we've got to save money, we've got to save carbon. Okay, I'm going to go on to some DevOps data anti-patterns, which I see are, we talk about photos or whatever, but in the DevOps world, in my 30 years of working in IT and my 15 years doing DevOps, I see so much waste. And what are some of these things? So the first one is data explosion through automation. So in the old days, in the early days of DevOps, before there was the term DevOps, we were doing all of this stuff manually. We're doing manual deploys and manual builds and manual testing. And we were doing this stuff maybe once a day or once a week, or there'd be a 3-week testing cycle or something like that. As we automate stuff, these things that were happening once a day or once a week are now happening every 5 minutes, or potentially every code check-in. Every time you check in code, or every time you're doing any of these sort of DevOps automation things, it produces output. It produces binary artifacts. It produces log statements. It produces documentation, et cetera, et cetera. So all these automated processes that we were doing infrequently, that are now happening very frequently, still produce the same amount of output, but on a magnitude larger scale. And this is not only DevOps, so we also do some work now around what some of our clients are calling digital operations. So we want to automate lots of digital operations. So for example, creating a new Jira project or getting a VDI, or all of these processes which used to be manual, we want to try and automate this stuff. I mean, DevOps into SRE, et cetera, it's all about automate, automate, automate. And every time you automate stuff, that's great, but these things tend to happen then a magnitude more quickly or more frequently, and you get lots more output. So this is a scale problem. The next one, but the bad data virus. So this comes from a piece of work I was doing earlier this year with one of our large clients. I was doing some work around service design. So let's look at all the services you have in your company and let's come up with a target state. Now, service data is typically stored in a CMDB. I know it's hard to read here, but it says CMDB, Configuration Management Database, if you don't know what that is, and that's typically ServiceNow. So in this case, it was a ServiceNow instance. I just don't have the logo on there, but these were a ServiceNow instance, and they were in the middle of migrating from a legacy ServiceNow instance to a target state one. So I was looking at the legacy instance, and a third of the services they had in their CMDB had been retired for 5 years. It was part of a company, in fact, that they had sold off. So the resources were gone, the people were gone, the teams were gone, but the data was still there. So I thought, okay, before we migrate, lift and shift to a new instance, let's clean up this old data. Not an easy thing to do when it's in production, but I had admin access, and there was one service in particular that was bugging me because it had the same name as a live service. So there was a retired service and a live service with the same name. I thought it was causing confusion, so I thought I'm going to delete this retired service. So I deleted the service. Lo and behold, it stopped flowing down to the new system. But the next day, when I logged in to ServiceNow, it was back again. And I thought, I just deleted this. So I'm looking through the audit trails and everything, and it turns out that that was not the source system, our service data. There was an upstream system which had service data. And I thought, oh man. And I thought, wow, I've just made I've made a bit of a discovery here. I'm going to send an email to all the people involved and say, hey, do you guys realize that I tried to delete some old data, and there's an upstream feed that just puts it back again the next day? And I thought, wow, Graham, you've done some pretty cool work. You're going to get a pat on the back, say, well done, Graham, for discovering this, and let's clean it up at source. But what actually happened is the next day I got a phone call from our stakeholder saying to me, Graham, we've had a complaint. You've just deleted data in production. Someone is complaining that why is this consultant got admin access to a production system and is deleting data? And I thought, oh dear. And actually, it was close. We could have lost the gig. They were not happy with the fact that I was doing this. So the data's still there, and this is 6 months later. And not only is it there, but they had some discovery tools. 1 and 2, they were in the middle of migrating from Discovery Tool 1 to Discovery Tool 2, so the data was being fed into there. The data was also, the CMDB was being fed into Snowflake, a data lake, and of course all of these cloud-based tools they've got at least 3 instances across 2 AZs for resiliency, and then all these other instances will have data backups. So again, we have a scale problem, and what I've talked about with the service data, it's not that much. But when you think about it in terms of all the other data we're storing, you think, oh, it's just a little bit of data in one system, but it's actually being stored in probably 10 times as many places as you think. And then there's also all the egress and ingress charges. There's the more amount of compute that you use to do searching and lookups. So and I'm going to segue a little bit, because when people talk about the cost of storage, people always say storage is cheap. It's only 20% of our cloud cost, typically storage. Most of it's compute. Yeah, well, the compute is running on data. And so if your data stores are half the size, your compute's going to be more or less half the size. So the argument doesn't really wash with me that it's not data, it's compute. Anyway, so again, we've got a scale problem. Okay, and the last one, delete nothing ever. So this is a result of the previous one. You try and delete something in production, someone sends an email, and you can get in lots of trouble. So our inclination then is, if in doubt, don't touch it. Just leave it there. It's also the philosophy of some of the hyperscalers. So Google's philosophy, and again, I get this from our Google tech lead in our practice. He says Google's philosophy is don't delete. Why do you need to delete anything? Just archive it. It might be useful sometime. Those Christmas photos from 2018, they might be useful sometime. Just keep them there, just in case. And so we don't delete anything. And it's funny, this week, Google has just put out an announcement, you maybe have seen, that they're going to start deleting Gmail accounts that haven't been used for 2 years. And they're selling it like we're doing this for security reasons, because a lot of these old accounts don't have 2FA and they can be hacked, etc. I don't believe that. I think they're doing it because they're starting to realize we have a storage problem. And we need to start cleaning some of this stuff up. And maybe we shouldn't just keep everything forever. So we've got this delete nothing ever because of FOD, or the fear of deleting data. Now, if you look at these typical DevOps tools I've got here, Jira, we don't delete Jira tickets anymore. In the old days, when I was young and before Jira existed, and we had Kanban boards, we had them on the wall with Post-it notes, and we had 3 columns: to do, doing, done. We'd have a sprint, we'd move the tickets over, and at the end of the sprint, we'd take the tickets and put them in the bin. You don't keep Post-it notes. But now, with Jira tickets, we keep them forever. We essentially don't delete them. Not everyone does this. There are good DevOps engineers that have good data policies to keep these systems clean, but there are a lot that don't. And so Jira instances get completely polluted with all kinds of garbage, projects, custom fields, etc. GitLab or any kind of Git repo. Yeah.
I'm more of a developer, not a DevOps
Yeah.
person. So if we are deleting Jira tickets, how do we maintain what was done when, why, how?
Yeah, so I'll get to that. Yeah. So, one of them is you have some kind of policy that we keep them for X amount of time and then we delete them. And some people, I have this argument, well, we need to keep the Jira tickets. There might be some information there. But then you will say, well, what is your documentation policy? Should you be should you have stuff in Jira that is important, or should it be documented elsewhere potentially?
Yeah, that's more of my question.
Yeah. So why do we need Jira tickets 2 years later? If there's something important in them, is that the right place for it to be? Yeah. Git repos. So a contractor comes in, writes some proof of concept code, stores it in your Git repo, and then he leaves, and it sits there. And 5 years later, someone says, what does this code do? I don't know. We better just leave it there. And well, you laugh, but it happens all the time. And all these tools get polluted with garbage, and we don't know what to do about it because we don't label the stuff. We don't know who owns it. The person's left, whatever. Artifactory, you know what artifact repositories are? So you have builds. In my day, and we had Java builds that were either snapshot or release artifacts. And snapshots you got rid of, we can delete that. Release artifacts, we need to keep those because they're potentially in production. So I've seen instances where people have misconfigured their Jenkins builds so that every build is putting out a release artifact. And then they get into Artifactory, and some of these builds can produce artifacts of 300 gig or whatever. Some of them are huge, especially in big companies, big financial service companies. So these Jenkins servers are pumping out release artifacts every 5 minutes, and by definition, once a release artifact's in Artifactory, you don't delete it, because once it's in production, it stays in production. And it's impossible. Even if you go to the owner of Artifactory and say, hey, these guys made a mistake. Oh no, we can't delete that. That's a release artifact. ServiceNow, what do you do with all these change and incident tickets from years ago? Do we keep them? Do we need to keep them? Datadog, we've probably heard stories about people using Datadog and getting 7-figure bills with all the log messages that are flowing through there because it's just a massive amounts of logging. So again, another scale problem. So we've learned that we cannot delete anything, or at least we cannot say delete. We get in big trouble. So what do? Well, let's call it data management or sustainable data management. So sustainable data management, what do I mean by that? 4 points. I'm going to work backwards. Automate your data management processes. Okay, sounds easy. Let's get an AI to do it, right? But AIs don't know what to delete unless you have some kind of policies or data retention policies. And this is, for me, the crux of the problem is we don't know what to do with our data and no one's told us. Now, enterprises are getting better at this. They're getting better at knowing what to do with customer data and credit card data. There's GDPR. So there's this right to be forgotten. So if you go to a large enterprise and say, what do we do with this customer data? They say, oh, we need to keep that for 7 years, or we need to make it deletable if they want, whatever. They know what to do. If you go to this data retention team and say, what do we do with JIRA tickets? You go, I don't know. What's a JIRA ticket? You know, and so they don't know what to do. There is no policy for JIRA tickets or source code typically in these large enterprises. So if there's no policy, we need to be opinionated about this. And this is where it gets tricky because of this fear of deleting data. But if we get opinionated, if we come up together and say, after 2 years of non-use, a JIRA project gets deleted. And you can, all these tools have all the functionality within them to have data retention policies. The trouble is we often don't use it because the people that are administering these tools don't know what the policies are. There are no policies, so we might get in trouble if we delete that, so let's just leave it there. So we need good data retention policies. Before that, we need a data classification scheme. We need to know what data is what. Is it production data? Is it non-production data? And fundamentally, who owns this data? It should never be owned by a human. It should be owned by a product or a service or potentially an application. But every bit of data you have in your company should be associated with a product or a service. And arguably, if it's not, you should get rid of it because it's not useful. But we're not quite there yet. And then before having a data classification scheme, you really need to know what data you're storing and what is it that we store, what's important for our company. So if you go back to the dark data, the stuff in the third shelf in the warehouse, if we had much better data management policies, we could potentially be saving 50% on our cash and our carbon bills if we just got better at managing our data. A couple of weeks ago, I did an internal course on sustainability, green ops, mandatory course. So I was doing all this course, and they were talking about hardware efficiency and how we're building better chips and chips that use less energy. And they were talking about software efficiency, how there's a whole green ops, there's a whole Linux foundation for writing greener software. There was not one mention of data efficiency. So I gave the course a very low score. But they were talking about moving workloads around where the sun is shining or where the wind's blowing. So Google's now spending a lot of effort looking globally at where there's excess energy, where people are using coal to burn to power data centers versus wind and solar. And I was sitting there thinking, moving workloads around where it's windy or sunny sounds like a hell of a lot more work than just cleaning up your data. And ultimately, it's all about efficiency. The best way to save energy or carbon is to be efficient. And we've known that for 30, 40 years, that it's just about turning the lights off when you go out at night, etc. We just don't really do that with data. And I think if we did do that, it's a really quick win to help us save cash and carbon. And I think that's it. Thank you.
Excellent. Great stuff, Graham. Thank you. Okay.
Happy for us to do a few questions, maybe?
I'm happy to, yeah.
Okay, all right.
Pizza's not here yet.
Pizza's not here. I think pizza might be downstairs. So, actually, it doesn't matter. We'll have some questions to see where we are after that. Cool. All right. Go on then, Paul. I'll let you speak.
All right. I'm trying to phrase this into a question, but look, this is a hard topic, right? And I think what I wanted to do to illustrate how hard this topic is that in the 1960s and 70s, and to some extent in the 80s, I work in media. I work in TV, and in those decades, the BBC deleted a lot of material. They deleted a lot of TV programs, a lot of video.
Why did we delete that?
And And we look back and we see, like, Doctor Who is obviously the clear example, but there are many other things that were deleted, and they were deleted at the time, not for the concerns we have today, but they were deleted because videotapes were expensive, film was expensive. They could reuse videotapes. It degraded. It was expensive. But clearly, in the 1960s, the view was, oh well, we've shown this on TV. It's been repeated a couple of times. We've not got any use for it anymore. And so the cleanup happened, right? And in that era, that was a perfectly, actually rational, totally objective, reasonable decision to make, right? And we look back with hindsight and we say, oh, why did they do that? Oh, that's awful. But at the time, it was totally rational. And so how do we know that the decisions we make today about what you've just talked about are not in that same category? How can we see 50 years into the future and say, actually, this data that we're deleting isn't of value? Because that's a really hard decision. Because if you think about that example, back then they thought that data was no value. They thought that was expended. TV was seen as a sort of ephemeral thing. If people have seen it, no one's going to be interested in it anymore. And so I think that's really hard. I think that's really hard. I'm not saying that's a counterexample, but I think that's really hard.
I think Christmas photos from 2018 we can be sure of, but I think there's not an easy answer to that. But it's going to be forced upon us because of the exponential growth of data, because of the demand for electricity, because of our need to get off of oil and gas. We are going to have to make hard choices, and we're going to have to be opinionated. And there is definitely, if I look at a Git repo of code written by a contractor 5 years ago, we don't need it. And
So is there not? Sorry.
Yeah.
Is there not some sort of archive storage that isn't energy intensive, that doesn't require energy, that isn't? So can we not write data that we're unsure about to optical, to whatever, that has longevity without consuming energy?
There's got to be a carbon cost to it. If you're willing to pay the cost of carbon, then you can store it. But I think that carbon cost is not baked in yet, really, at all. And it's going to. I imagine it will happen soon. Yeah.
Interesting stuff. Good stuff. Okay, cool. Let's go to Ono.
I'd like to take the subject to the other end of the spectrum. You mentioned earlier that every bit of data should have an owner, whether it's an application or a service or a product.
Yeah.
And if it doesn't, it should get deleted. But my question is, doesn't this go against the whole idea of big data and keeping every bit of data and potentially seeking value in it?
No, because so if you talk to a data scientist, one of the biggest problems they have is finding the nuggets of data they need in the mess. And I often make the analogy of gold mining. Yep. If you're mining for gold in Peru or wherever, typically what will happen is you'll have a little mine, you'll get all your gold, you'll have a nice pile of gold nuggets, and you'll have a much bigger pile of tailings, they're called, or waste. Right? So the data scientists, they want the gold nuggets, they don't want the tailings. And and as you saw some of those surveys, even data scientists will say 90% of the data we don't even use, we don't even know what it is. So if we can get better at getting the gold and getting rid of the tailings, I think that's what we need. There's absolutely data that is never going to be used. And we just have to know, get better at understanding what that is, what's important to a data scientist, and what is meaningless. Yeah.
Great, cool. Yeah. Okay, next question over here.
Hey, hi. Back to you. I interrupted you for the same question.
Yeah.
Where does my artifacts, or basically the history tracking lies? Why I did a change? Because again, I come from developer community, not from someone from DevOps.
Yeah, so if it's code, it'll be in Git. If it's in a documentation tool, they should have versioning. And then I would say, what do you need in Jira for?
So, if you ask me, I've been working in some agile projects, and somewhere I've heard for sure, agile says low document or no document. It's all your tickets that define.
So if you make that decision that all our documentation is Jira, then that's fine. Then get rid of your Confluence or get rid of your SharePoint, but don't have it in both places, right? This is our strategy for documentation. It's Jira. Fine, then keep it. But if your strategy is our documentation is in Confluence or SharePoint, we don't want it in Jira. If there's something important in Jira, we should be putting it in Confluence, and then we get rid of our Jira tickets. But you don't want it in two places. Like, if I need to look at an issue from a year ago, do I look at a Jira ticket? Do I look at the incident ticket in ServiceNow? Do I look at the Git history? Do I need all three? I don't know. Maybe you do. Probably not. So which one of those don't you need, and then get rid of it? Yeah.
Okay, good stuff. Thank you. All right, I'm just going to go a bit further towards the back and involve the other half of the room for the next question. Go on then, Chris.
Billy Graham.
I just wanted to introduce another well-known acronym, FUD. FUD reminds me a little bit of FUD. Which I wonder, I don't know, maybe I'm being...
Starts with a swear
fear,
word.
uncertainty, doubt.
Fear, uncertainty,
doubt.
And doubt. Okay,
yeah.
Nice.
So
okay.
I don't know. I think my experience of too much data is when I hit the wall in terms of running out of data, then I do a sweep through, and then I look, okay, what haven't I looked at for 2 years? Then hit the delete button, and basically I leave it until I hit that wall.
Yeah.
And I think if we're not deleting data before we actually have to, maybe it's not priced correctly.
Yeah, it's kind of like putting all your stuff in your loft, and then your loft gets full, and okay, we got to deal with this, right? I think having automated policies is the best thing. If you rely on humans to delete stuff, you can there's always human error, but there's always this fear of deleting data. What should I do with it? If you have automated policies that you've agreed on, okay, we all can agree we're going to delete Jira projects after 2 years of inactivity. And then it just happens, and everyone knows, that just happens, and then it's fine. But if you're sitting there thinking, should I delete this Jira project or not? I don't know. I'm running out of. Sorry.
With clothing.
Well, if we bought less clothes, it would probably be okay. But I think again, it's a scale problem. It's a scale problem.
Okay, probably just time for one more question. Any more from the back? Everyone's looking at the floor. Yeah, go on then, Mr. SRE. You can ask a question.
Yeah, I wonder just about kind of habits and setting expectations. Take software as a service as an example. 7-year-old projects, you could probably consolidate a lot of that data and progress that teams have made in some reporting, maybe a PDF of progress, stories completed, burned down, all those kind of stats that agile scrum teams like, scaled agile framework, all that crowd, and then maybe like a CSV with the name of each user story and a description. I think especially in the software as a service world, there's a lot of if we could choose the settings before we joined in, we could probably categorize and minimize a lot of excess redundant data and have a plan for it. So I think your talk's been going on about that a little bit, but do you think there's more that could be done in the software as a service space? Because apart from the cloud and using it directly, that's a lot of people's use case just in their digital state.
It is, and I think up until now there's been this meme: software storage is cheap, right? And all the vendors have essentially storage is cheap because they're not charging very much because they haven't had to. I think that this is going to change in the future when we start hitting limits in terms of when we have to start reporting on carbon. And when all of our firms have to start reporting on scope 3 emissions, which are the emissions produced by data centers, when there becomes an electricity crunch and price, you have to fight with residential people or versus data centers, who gets the electricity? Well, if there's not enough supply for the demand, the price goes up. And once the price goes up, then these software as a service vendors are going to go,